Yes. So, good evening, everybody. It's a little bit flashy on my side, but okay, I try to keep up with it. So, yeah, good evening, everybody. Thanks for your interest and thanks for attending here. I know it's Friday evening in Iran and also Friday evening in everywhere else in the world. So it's not the optimal place to sit and listen to a webinar, but that's why I want to thank you for being here. As Fatima already said, my name is Shadan Saderian, and today I'm going to give a brief introduction to the topic AI and the future of work. Oh, okay. And I'm learning how to work with Teams today. So I'm a Zoom person. So sorry for any weird behavior from my side. It's not intentional. So yeah, my name is Shadan Saderian. Obviously, I come from Iran. And the reason I'm running this in English is that we were expecting people from all over the world. And the other case is that I have learned a lot of things in English. So I also went a little bit for my comfort. We might change that for the workshop if it turns out that all the attendees are coming from Iran and are Persian speakers. So yeah, my name is Shadan. I come from Iran. I did my bachelor in software engineering at Qazvin Azad University in Iran. And then afterwards, I moved to Germany to do my master. I got a master in computer science from University of Bonn and RWTH Technical University of Aachen. And during my master, I got very interested in the topic human-computer interaction, and that led me to do a PhD on that topic in Office Institute for Information Technology. And during my PhD, I was granted a scholar as a visiting researcher at the Max Planck Institute for Biological Cybernetics. After I finished my PhD, I moved to Fraunhofer Institute, which is a research institute with different branches in Germany. As a postdoc researcher, and finally I ended up where I am now at University of Siegen as a postdoc researcher as well. So in the last 7 years or so to say, my research was mainly focused on designing interaction concepts and interaction and experience design with automated systems. In my PhD, I was mainly focused on designing interaction with automated vehicles. And then I moved to different types of interaction forms, such as interacting with AR and VR interfaces. And then where I am now, I'm mainly working on a project which actually deals with interaction with management systems or AI in management systems or collaborative robots in industry production lines. So that's it from my side. And before I move, سلام، من اینو به انگلیسی فارسی من من این پرزنتیشن رو به انگلیسی آماده کردم، ولی هر جایی که فکر کردیم که سوالی هست یا چیزایی که من ارائه میدم مفهوم نیست، حتما ریز هند کنید، سوال بپرسید و من خوشحال میشم جواب بدم. So I move to the next slide. So you might get surprised that why is the title of the first slide is what is automation, while the actually title of the whole presentation is AI and the future of work. The reason is that I would like to go back a little bit in history, in 1700s, when actually the Industrial Revolution happened. And back in the time, if you look at the topics people were talking about and articles and so on, everybody was talking about that the machines are coming to take our jobs. So people in agriculture were worrying that they're not going to work on their lands. People in factories were worrying that the machines are coming. And now when you look at the articles today, you see a lot of titles on the newspapers that robots are taking our jobs. So basically the machines have turned into robots, but the title is kind of saying the same thing. So if you go through this timeline, you can name it actually automation is taking our jobs. Not specifically AI, but generally the automation. So what is automation? The Britannica Encyclopedia defines automation, the application of machines to tasks once performed by human beings or increasingly to tasks that would otherwise be impossible. Although the term mechanization is often used to refer to the simple replacement of human labor by machines, automation generally implies the integration of machines into self-governing systems. I know, that's a long description, but what does it mean? Let's make an example. So we all have heard the word automobile, or as we say in Farsi, automobile, and that is made out of two parts, auto and mobile. Auto refers to the automation, and mobile is the mobility. Basically, it's a tool to automate mobility. Before the automobiles or cars come on the roads, what happened was that people were walking, using animal powers and so on to fulfill their mobility goals or commutes. Then what happened? The car was invented to augment human. And how was it augmenting human? It was helping the human to carry heavier stuff, travel faster, and for longer destinations. But back in the time, when you look at it, people were basically having the full control. It was the driver who had to think, make decisions, and control the movement of this whole automobile thing. And that's actually what we call mechanization in terms of automation, because it's mechanically controlling a tool. But as we move on this timeline, as you can see, I'm not sure if you're seeing my cursor, I hope you do. But as you move along this axis from mechanization to automation, you see the picture in the middle, which is what people are talking about today, which is the next generation of automated vehicles that come on the road and can drive parts of the way, like, for example, highways in an automated mode, and people are able to do other tasks like surfing on internet, reading, and so on. And then, but there is still a steering wheel, and there are still situations that this car is not yet programmed for or is not able to handle, and then you have to take over the control. And once the situation changes and the car can handle it, it tells the person, okay, I'm done, you can take over, or you can go back to your reading, and then I will take over the control. And hopefully one day we come to the fully autonomous cars, like third picture, which is full automation, where you can sit in the car and do whatever you want to do, like a train trip, without even having a driving license. So the question is that why is automation good for? What is it? Why is it good actually? Why do we want automation? To augment our abilities, which means that we want to be able to do things that we wouldn't normally be able to do, like lifting heavy things, which is in mechanization, or calculating huge numbers and processes, which is augmenting perception, cognition, and so on. So like processing units of your brain, or sensing things that we couldn't sense normally, like having these magnifiers that, or sensors that can see, for example, things in nanopixels. And these are the augmentations that automation brings to us. And the second thing is that it increases comfort. See how much less work you have to do when you automate things. And the third part is that reducing costs. Imagine you use a machine or an elevator simply to take a refrigerator upstairs in a building than hiring two men carrying it up. So that's cheaper, definitely. You just have to pay for the electricity. So these are the three reasons that automation is good. But going back to the previous slide, and we saw that timeline, we know that automation doesn't come from one day to the other day. It comes in very gradual steps. So basically from the time that person does everything, the human does everything, to the part that the computer or the machine does everything, and we don't need a human at all in the cycle of the task. So these are the 10 levels defined by Parasuraman, who is a very well-known researcher in defining definitions, explanations in types and levels of automation. So Parasuraman defined these 10 levels of automation. And interestingly, these 10 levels are defined in 1980s. And if you read through them, you see that it's mostly about cognitive processes. It's about decision making. It's not about manual power anymore. It's not about shifting things and moving things around. It's about understanding, getting data, understanding it, and then making decisions and acting accordingly. So it's basically brain power that he's talking about, where from level 1, the computer offers no assistance. The human must take all decisions and actions. To level 10, computer decides everything and acts autonomously, ignoring human. And for example, let's also look at level 6. The computer allows the human to restricted time veto before automatic execution. And as you see, as you come down from level 1 to 10, the engagement of human in doing the task reduces and the engagement of automation increases until it doesn't need a human at all. So we had that, and then we think that we will one day reach to level 10. And what is level 10? Level 10 was that the automation doesn't need the human at all anymore. And that's what we call AI, artificial intelligence, because that's an intelligence that's not coming from the human side, human brain. And now what do we read? What are the perspectives in the society about AI? There are two sides of it. One side, which is very, very dominant, unfortunately, these days, is that AI is going to take our jobs. We are going to go jobless. Robots will take everything. And the other side also thinks that, yeah, robot will take some jobs, but also it's creating new jobs. So let's see if automation is really taking our jobs. Maybe some of you already know this picture. This is a car manufacturing company. Conducted like everything in the cycle of manufacturing the car after the design is done by robots. And this is already happening for more than a decade, actually 2 decades maybe. And this is not a new thing that we have this in production lines of cars. But also what we had a couple of years ago was that Apple replaced 60,000 workers with robots at China factory. And this was under the case that China is known for low prices on human labor. And the salary of each of these people was something around $5 a day, which is in terms of the money Apple pays to its employees, is a very, very low price. But then paying automation was still cheaper than paying these people. That's why these 60,000 people were replaced. This is a warehouse where robots are moving around things. These are humans replaced by robots. This is a robot which can make a house in 2 days. So no worker needed to put up the bricks on top of each other. This is our futuristic, near futuristic pizza delivery guy. So, I mean, don't get surprised if you once order pizza and this guy shows up at your door. And most probably the pizza will be still warmer. And these are our new farmer guys doing farming, creating our vegetables, planting our vegetables in a greenhouse. And we think actually that automation is going to take only manual jobs. But recently, lawyers are feeling the threat that AI is going to take their jobs, as well as managers. Because basically, what does a lawyer do? They know the laws, they know the regulations, they gather data from the courses, and they make a mapping between the data gathered, the laws existing, and they solve the case. Same applies to managers in a lot of cases. So as we see these examples, it's not just manual work anymore. It's also coming to the intellectual work and skills. Then the question is that, is automation taking our jobs? Yes and no. Yes, automation will take whatever it can take. But no, it takes time until it does it. Look at this picture. This picture is published by Power and Light Company in 1960s, saying electricity may be the driver. So we are more than 50 years or half a century away from that. And I haven't seen such a car on any highway. I'm not sure if you have, but I don't think such a thing exists yet. And I work in car industry. So that shows that actually there is a long way until we come from human doing everything to automation doing everything. So what happens in between is that we will have human automation collaboration. And that is that there will be teams of humans and automations in forms of robots, AI, cobots. Cobots are collaborative robots, working together on specific tasks, carrying out different parts of the tasks, or sharing the tasks with each other, and fulfilling the goals of the task. I just make a pause here. Are there any questions up to now? No, I don't see the participants list. That's why I need a microphone on if there is a question or not.
Okay, I have a question related to automation. What do you think about the Tesla cars? For example, you talked about these kind of things, but Tesla at least did half of that, I think.
We'll come to that. There is a slide on that.
Okay, okay.
But thanks for the question. Interesting.
No problem.
Any other? Okay, I'll move on. So, as a human-computer interaction designer, or as a person coming from IT sector, so if you're going to think that that is the AI, that is the automation that you're going to build, what do you have to know? How to design. The very first and the biggest question is that if you're going to design automation, how are you going to design automation? Well, we know that by now from what I told, that we want to make automation to enhance humans, not to replace them, because we cannot replace them yet. And that's hopefully also not our complete and final goal, because there will be things that humans are better at. But let's focus on this. Imagine you go to your work tomorrow, your boss comes to you and says that, hi, this is Mr. or Mrs. X. From today on, you're working together as teammates on your tasks. There have to be some constructions, some laws, some agreement between you and Mr. X that this teamwork functions. There have to be an agreement on the tasks, and there have to be, and this agreement should be based on the skills, what you can do and what Mr. X can do. So basically, we have to answer two questions. What are humans good at, and what is AI good at? And that answering that question helps us to allocate tasks to these two partners of this collaboration. Humans are good at handling unexpected situations. So far, what we have as robots, automation, or AI are either programmed by like some programmers and can handle specific tasks, or are using machine learning and have learned through the data that they have gathered and the algorithms that are helping them to learn these situations. But that's limited to those data. But humans are much more advanced than that and have a lot of aspects. For example, you might have a robot that works in an industry setup and have learned data just specific to the tasks. But a human has also cultural, societal, and so on backgrounds. They know the climate of the area they're working at, for example. And that's why when something happens, that they can come up with new solutions. Humans can understand social situations. Humans have cultural backgrounds, learned experiences from their relationships with people, and are much better still at social situations than AI or robots. Humans are creative. So still the data for machine learning and AI, existing AI, is limited for being very creative. They mix up sometimes different combinations of the solutions they have, but they don't come up with completely brand new ideas like humans. That's why we have so many varieties of humankinds, but not machines. because every human has a specific character, adding different ideas or concepts or pieces of data together to come up with a new constellation of that. And humans have empathy. So imagine a nurse robot. I bet that nurse robot can make the bed much more perfect than a human, and every day the exact folds the same way. They will never forget to bring you your pills when you're at the hospital, and they will never forget the time. They will always be punctual. But I'm not sure if they come to you and then if you make a specific face expression, if that face expression does not exist in their database, I'm not sure if they would understand. Or for example, imagine you're an Iranian in a German hospital. I'm not sure what the interpretation of that robot is of your face expression, because they have actually learned German face expression. So on the other side, we have to know what are the robots good at. Robots can multitask, and which means that they don't get overwhelmed by a lot of data. So a robot can simultaneously calculate a multiplication of two very big numbers and sing a song for you without getting distracted. I can give you 10 seconds to try that for yourself. Microphone off, please. And but I bet none of you can do that. If there is someone who can do that, I would really like you to raise your hands and do that for all of us, because it's proven that humans are not able to do such a thing. And then there is that robots do not get tired, bored, or impatient. There is no robot that nags that I have had enough of working, I just want to take a rest. Or there is no robots can do repetitive tasks forever, and they can wait forever without even complaining about it. Robots don't take things personally. You can criticize a robot about the way they're doing their tasks, and they won't get offended. They just take your critic and change the approach they're doing the task. And they have unlimited cognitive power. So basically they can save a lot of information. They never forget, they never get overwhelmed, and they never get distracted. Now when we know this, we can think that what kind of tasks maybe are better fits for humans and what kind of tasks are better fit for robots for every system that we are building. The second thing we have to have in mind is the application domain. For what application domain are we designing this automation? Are we designing for a chess game, or are we designing for a safety critical domain like an airplane cockpit? So there is no question about that both of these applications or automation should work. A chess game with AI, the AI should be able to actually know the rules of chess, should be able to play with you in turns, and should be doing moves of the figures that actually make sense relative to your movements. So that's basically the functioning. The AI should be able to function. And on an airplane, the AI should be able to do the tasks properly, like taking off, navigating, and flying to the destination and landing. So these are basically what the whole concept of the system should do, which is in the back of the system, behind the scenes. And for example, when you move a chess figure and then the automation doesn't do anything in return, that shows that it's not functioning properly. So the system is kind of not usable because the usability phase, or for example, if it does all over the time with one figure the wrong types of moves, then it's not a usable system. Or if it doesn't allow you to move when you have to, when you want to. On the other side, when you see that, for example, when you're a pilot in an airplane cockpit and you want to see a specific type of information, and you press a button to see that, if that information doesn't pop up, this means that the system is not usable for you anymore. Or for example, when you have less than 5 seconds to react to an event which is very safety critical, and the system doesn't show it to you in a very obvious and salient way, the system is not usable. Or if you need to analyze a bunch of data to make a decision in a matter of seconds, and then the display shows you a list of hundreds of types of data, which overwhelms you, the system is not usable. So what I'm talking about is that these all, to make a system usable and to make it actually work, we are talking about pragmatic or functional qualities of a system. But is it all about it? If you look at job applications, you see a lot about UX designer and UI designer. When we talk about UI, and unfortunately, I am a little bit out of topic, but I was recently joining a Clubhouse discussion, and I recognize that many people are talking about that. I'm a UI designer, I'm not doing UX, and or the other way around. But these are kind of tangled together. So you cannot separate UI from UX really and saying that, okay, I don't care about one part of them because that's the system I do, and then that's what I want to deliver to the customer. But then let's go to the UX. So UX is talking about the experience you have. So maybe in the cockpit, UX is not the most important thing. So for sure, you enjoy a more beautiful, a better experience with the displays and so on, more than an ugly one from 1960s. That's no question. Or, for example, you might prefer touch screens in comparison to knobs that you have to turn on the cockpit, because that gives you a better and smoother experience. But now let's go back to chess. Imagine you have a chessboard, and when you have a checkmate, then all the figures of your partner falls down, showing that, okay, they lost. Actually, that's a metaphoric picture of, oh, they all died on a battle on your chessboard. And that gives you maybe a better feeling that, oh yes, I won this battle. And that is the experience you gain through the use of the system. And that is called hedonic functional characteristics, which is hedonic means what relates to beauty, what relates to experience, and what relates to what you feel and what needs get fulfilled through this. The next thing I'm going to talk about is performance versus meaning. Imagine you want to make a coffee cup and you have a bunch of coffee beans. There are two ways to do this. One way is to use a coffee machine and move the grip, and that's it, get your coffee cup. The other way around is to get a traditional grinder, grind your coffee manually, and then brew your coffee in an espresso brewer, and then you get the coffee. So imagine now two scenarios. You have 5 minutes to get ready, drink your coffee, go to work. Which way do you use? I think the second one, because you want things to go parallel in a very fast way. Now imagine you want to make a cup of coffee for your loved one. And which one may be better? So I think maybe the first one is not a bad thing, because when you bring the cup of coffee, you have grinded the beans yourself, you have put the effort of making the brewing the coffee, and you are the one who are the cause for this delicious coffee they are getting. Basically, through the first way, you feel more competent, you feel skilled, that I can make a perfect coffee like a barista and then give it to my beloved one. And on the second one, you feel the freedom and authority that I can manage my life on my own by letting the coffee cook, and then I will get ready. So the coffee beans are the same. The cup of coffee is the same, but the experience that you're gaining through these two ways are completely different, and the needs you're fulfilling are completely different needs. So you have to really take care, what do you want to reach with the design of your product? And that is, for example, if you want to make a very fast and efficient product, maybe you want to go for the second way. And if you want to going for competence and giving the people the feeling of being skilled, then you might want to ask them which part of this first process makes you feel more skilled. And they might say, I like brewing coffee. and then you automate the very first grinding part and give the second part to the person, so they have a feeling still of being competent while you're automating one part. Another example for performance versus meaning. The picture on the left side, this guy is working with his new colleague, Mr. Robot, let's call him, or Mrs. Robot, and they're working together on specific tasks. And they are, like the robot is able to cut specific pieces, handed it to him, he makes changes, he hands it back, and then back and forth a couple of times until the perfect product is made. The robot makes no mistakes, is very fast, is doing everything right on point. And the collaboration works so well that they have more products than ever that this person has achieved before. On the picture on the right side, these two people are working together. They are prone to make human errors because they are humans. They're prone to have delays because they might get tired or sick. But on the other side, let's talk about the break between the work. And let's talk about the time you want to have a tea or coffee with your colleague to take a break. Can the guy on the left picture go on a break with his colleague? No. What about the guy on the right picture? Yes. If they get on well with each other, I think yes. And then, what about the guy on the left side? Can he talk about the football game yesterday with his colleague? No. What about the one on the right side? Maybe yes. And the other thing, on the right side, let's say the person on the right side of the picture is told that from tomorrow on, the person in the front with the darker colors skin color is going to be your boss. Would he accept it? Yeah, maybe. If they're told to that he has to take care of the situation, yes. And then let's see the other side. The person on the left picture is told that from tomorrow, this robot is your boss. Would he accept it? I don't know. How many of you would accept a robot being your boss? Just raise your hands. I don't see many raised hands here. That's interesting. So my question is that when someone comes and tells you that there is a person who is much more capable of you in doing the task you're doing, and this guy or woman is going to be your boss, you accept it. But if I tell you that there is a robot who is doing everything 10 times better than you, most probably you will be a little bit not really happy to hear that situation. So that's basically what you're designing for. Are you designing to reach your performance goals, or are you designing for meaning? And meaning here is that talking maybe to your colleagues, but maybe also this person on the left picture finds the meaning in being really skilled and being able to work with a robot. These two concepts are not necessarily contradicting each other. It's just knowing that if you want to design for performance, maybe you should keep meaning in mind. Because if you forget about meaning, you might have a really high number of products with really good qualities at the end, but you might lose your staff, for example, because they cannot take it for a long time. Here is our Tesla example. So the next thing I want to talk about is trust. When you're working with people together in a team, you have to build up trust. So they know that they are reliable, they're doing their part of the work in a perfect way, and then you can work together and count on them. So now let's read this title of the article from the news from, I think it was 2 years ago, from The Guardian. Tesla driver killed while using autopilot was watching Harry Potter, witness says. So there are two things in these headings. First of all, the autopilot. Tesla has made a huge mistake naming its level 2 automation autopilot. Although Tesla is one of the first comers for automated driving industry that actually is making things happening on the road, but what they did as a mistake, they called the level 2 automation autopilot. What is level 2 automation? Level 2 automation is a car which can drive in an automated way in highways, but the driver has to always have the hands on the wheels, eyes on the road, in case something happens that the car cannot handle. But what they call this for the marketing and selling is that autopilot, which is basically what we use, the term used for airplanes, which are able to take off, navigate, and fly to the destination and land. And knowing that term and mapping it to an automation system like the Tesla existing now, cause the driver think that I can sit and watch my Harry Potter movie and overtrust the whole system and causing accidents. So when we are designing automation, it is a very thin line where we can design the trust, where the trust equals to reliability. If we trust a system as much as it's reliable, then we can have a really good collaboration between human and automation. I make an example again with the Tesla car. If my Tesla car tells me that, hey, I can drive perfectly on the highway, but I cannot handle streets of a city. So on a highway, then I can sit back, do my things, read my book, and then the car will drive. But then if I go, for example, on the highway and my trust gets bigger than the reliability, and then we exit the highway, we go to the city, and I keep reading my book, then the Tesla accident will happen. And that's called the misuse of automation. Because I trusted the car more than it actually was reliable and more than it could handle. And the other way around, the car tells me that it can perfectly drive on the highway. But then I say, no, I don't trust you. I just want to do it myself. And then I drive in a way that I might get distracted, I might daydream and so on and make errors that can cause accidents, which the car wouldn't do because the automation works better than I do in that case. And I control the speed in a way that I use more fuel and it's not efficient and it has more cost for the driving, which the automation wouldn't do. So basically, by my behavior, where my trust is less than the reliability of the car, I'm disusing this automation. Basically, I'm canceling all the effects of the automation. So this was one of the other cases that we have to really
consider. Sorry to interrupt you. I think someone has a question here.
So sure. I'm almost on the last slide though.
Okay.
Hang on. And then I'm finished.
Yeah, so you can finish and then we can ask our question.
Okay. Do you still see my screen?
Yes.
Okay. So basically that was the last thing I wanted to talk about designing the automation today. And I finished this presentation with one sentence which I really deeply believe in. So if you call products things, then everything is designable. So we can definitely design AIs that are coming to one day take our jobs in a way that we want them to be. And thanks for listening, first of all. Thanks for being there. This was a very brief introduction of human automation and future of work, or AI and the future of work. And we are going to have a workshop on this topic one day, I think 6 hours. No, I don't think, I'm sure. 6 hours of workshop on this topic, where we look into the fundamental concepts of human automation interaction, designing automation to augment rather than replacing humans, and designing interactions for humans in terms of input-output modalities. So, and this workshop is going to be in an interactive way. So I'm not going to talk for 6 hours. We're going to have 3 different discussion sessions, and we're going to have a kind of virtual hands-on sessions for brainstorming and coming up with our own interaction concepts. That's it from me. Thank you. And I stop my presentation now by, I don't know how to.